Hello, this is Marco Mota, Windows Server 2012. Windows Server 2012 is mainly deployed in a virtual environment and designed to run on some high specifications, such as high storage, high networking, and high computing. A minimum of 512 megabytes of RAM is required, but typically we need a minimum of 2 gigabytes to do something useful. It will take up to 32 gigabytes of disk space, and it supports up to 64 physical processors, up to 640 logical processors, which 320 of them have Hyper-V. Today, we live in a world where physical processors often has many cores, different compute units, and sometimes those cores supports hyper-threading. So occasionally there are two threads of executions at the same time. So we can get a large amount of logical processors if we use Windows Server 2012. There are many new capabilities that did not exist in the previous version of Windows servers, such as Hyper-V, remote desktop services, file classification infrastructure, web applications proxy, PowerShell, and the list goes on. Windows 2012 can use up to 4 terabytes of memory, but realistically, not many applications can use that much memory. Most applications will max out way before they reach the 4 terabytes of memory. Therefore, memory is not being used in an efficient way. So it's much more efficient to use virtualization. By using this technique, we can cut the hardware resources into lots of virtual machines and assign them a certain amount of memory, a certain amount of virtual CPU, and so on. Each virtual machine can be assigned up to 1 terabyte of memory and 64 virtual CPUs. Using dynamic memory, we can efficiently allocate memory as is needed based on the actual work that is happening within a virtual machine. Windows Server 2012 offers SSD support. Traditional hard disks suffers from performance penalties because they use spinning plates and the head has to find the information. So the head has to move around the disk in a seek action and try to find where is the piece of data. And as it continues to perform those seeks, it is negatively affecting the performance of the system. SSD drive that are supported by Windows 2012 Server have no moving parts, therefore do not have seek penalty. That is why they offer such a great performance and higher speeds, especially for non-sequential actions. The fragmentation is disabled automatically for SSD drive because since there is no seek time, fragmentation does not really affect the performance. In Windows 2012 Server, partitions are aligned to optimize SSD during the creation of the partition. So we can add to our system a number of SSD drive, and we can create a disk where a certain portion of it can be SSD, So basically, we can get a tidying capability in the native Windows storage. In the native, this Windows Server 2012 will detect the hot blocks, where the hot blocks are, and move them around the disk to give us the best performance. If we have an external storage enclosure, we can actually create a cluster storage space. Thank you.
Hello everyone, my name is Carlos and I'll be walking you through the last slides of the presentation for the Windows Server 2012. In order to have a better understanding of the architectural structure of the Windows Server 2012, we first need to take a look at the earlier versions of the operating system, starting with the MS-DOS, which is the first OS and consisted of 8 kilobytes of memory resident code and was developed around the 1980s. Further development of this OS integrated features to include a GUI interface by Microsoft, which later called the OS Windows. MS-DOS continued to be an essential part of the Windows OS until the Windows Millennium Edition is released. After Windows Me Edition, we have the introduction of Windows New Technology, or NT, which introduces a new 32-bit OS and eliminates MS-DOS dependency. Later on, NT is redirected to the server market, where it continues to be the dominant operating system until the introduction of Windows Server 2003. In the following years, Microsoft continues to develop the Windows Server brand with different releases and versions to include Windows Server 2012, Windows Server 2016, and Windows Server 2019. Since the Windows Server 2012 architecture structure did not change dramatically from Windows Server 2008, which utilized the Windows 7 kernel, which was developed from the New Technology kernel, it can be assumed that the Windows Server 2012 is considered a version of the Windows New Technology NT operating system. And there we have it. So basically, it's divided into the hardware layer, which has the CPU, interrupt controllers, memory, and then it has the hardware abstraction layer, which serves to as a mean of communication between the hardware and the kernel. And the kernel is divided into two, which is the executive layer, which contains the processes, threads, virtual memory, etc., and the driver layer, which is the file system, volume manager, TCP/IP stack, and on top of that, we have the user mode. Now let's take a look at virtual memory. So Windows 2012 is the first OS to eliminate the 32-bit architecture and only use the 64-bit architecture, which means that a virtual address are 64-bit long, which means that it allows for 2 to the 64 bytes of virtual address space, which is about 16 exabyte, which is about 4 billion times the size of virtual address space for 32-bit architecture. Since the address space is so big, it had to be reduced to 16 TIB, 8 TIB for user space with the lower address half, and 8 TIB for the kernel space with the higher address half. The 64-bit addressing mode, also known as the long mode, is a superset of the physical address extension PAE, which is also known as the page address extension, which is a memory management feature of the 86 architecture. Based on this information, it can be said that virtual page can be in one of three states. The free state, which means that the page is not being used, the committed state, which means that the page is being used, and the reserved state, which means that the page is not available for mapping. To provide standardization across different versions of Windows, Microsoft defined a set of codes named the Win32 Application Programming Interface. And this is basically a library of procedure which makes the system calls to get work done, or the work in the user space library procedure. Some of the functions to manipulate virtual memory within this library are shown in the screen. We now move to the file system, which is called the Resilient File System and was introduced in Windows Server 2012. This file system was codenamed Protagon and is a Microsoft proprietary file system which replaces the file system introduced in Windows NT. Resilient File System was designed to overcome problems that have become significant over the years with the introduction of New Technology File System, or NTFS. Some of the improvements include automatic integrity checking and data scrubbing, built-in handling of hard disk drive failure and redundancy, and storage virtualization and pooling. Some of the commands in the Windows 32 API library to handle this file system are shown in the screen. We now move to process management. In Windows Server 2012, all processes are created equal. Processes create handles, and handles cannot be passed to other processes. But there is a way for a process to make a handle suitable for another process and then provide the handle. Each process in Windows is created in a single thread, but a process can create more threads. So processes utilize different methods to communicate in the same manner that they use different processes use different synchronization mechanisms. Some of the different methods to communicate include pipes, sockets, remote procedure calls, and shared files. And some of the synchronization mechanisms used by the processes include semaphores, which is a variable used to solve critical section problems to achieve process synchronization in multi-level environment, mutexes, which is basically locks, and all of them are kernel objects. Then we have critical section and events. Some of the functions in the API library to manipulate processes are shown in the screen. This will culminate this presentation. Thank you for your time and have a great day.
My name is Tristan Lehman. I am in Structured Computer Architecture, doing the Windows Server 2012 presentation with Carlos and Mark. I wanted to talk about virtual memory. Now, it's already been explained a bit in the earlier parts of this presentation, but I wanted to give a more in-depth analysis. So virtual memory allows computers to simulate that they have more physical memory than they actually do. Most virtual memory paradigms are handled by the operating system exclusively. There are virtual memory paradigms that handle certain parts of virtual memory management via hardware rather than the operating system. We'll get into those much later. The basic function of virtual memory is paging and the creation of pages, and before its creation, programmers had to keep a hawk's eye on memory availability and location. Now, paging is the technique for automatically changing overlays, and overlays, to be clear, are parts of a program which used to be split up on the hard disk and main memory. The idea is that one overlay would be pulled in to run a particular part of the program, and then at some point in its execution, another part of the overlay would be brought in or switched out with that run one, and the next part of the program would run. After its creation in the 1960s, the automatic changing of overlays, called paging, freed up a vast amount of brain power for programmers. They no longer needed to worry about physical memory addresses and keeping track of them in their programs. Now, in Windows Server 2012, as with most standard operating systems made in the last decade, Windows Server 2012 uses a standard page size of 4 kilobytes. This can be changed if the operator so chooses, and there is an approximate page size in terms of a conception that 1.5 times the RAM installed on the machine is the correct size. However, paging on a server leads to a dramatic loss in performance. If your server is paging, then it has too many things running on it or needs more memory. Now, page faults in essence are common at the start of the program's execution. However, as it continues to execute and as it ages, page faults should fall off. This is due to the locality principle of paging and the accuracy of the working set. That idea being that programs often refer to the same number of pages or the same set of pages consistently as they age or as they go on. If they do not fall off as the program ages, then the page replacement policy algorithm likely needs to be replaced with one that works better for that program's specific execution. We'll get into that a little bit. There are two common page replacement policies: the least recently used, which is the LRU, and the first in, first out, which is FIFO. So least recent used is a page replacement policy that opts to evict the page least recently used as the probability of it not being in the working set is high. The idea is that if that page hasn't been used in a really long time, then that page probably isn't in the working set anymore, so it gets rid of it. This fails spectacularly, though, on programs that require you to loop back to the beginning of the program. So if it has to do 10 things and then go back to the first thing it does, this replacement algorithm will fail spectacularly. First in, first out ought to evict the least recently loaded page, independent of when that page was last referenced. It's a pretty common one that happens often, but it too has places where it can fail. As stated previously, Windows 2012 does have pages and can have pages, and they exist in 3 states: free, committed, and reserved. However, your server should not be paging. It leads to a dramatic loss in performance and should be avoided by running either less programs on your server or giving your server more memory, which is pretty easy considering memory is pretty cheap nowadays. Unlike overlays or paging, segmentation solved a big problem with the way virtual memory was handled up to this point. It was always one-dimensional. As a result, segments could grow and shrink with little fear of collision. They were completely independent address spaces, and the creation of segments also allowed the sharing of procedures or data among several programs. It seems to be the story with Windows Server 2012 that memory is key. Consistent lacks in available memory can lead to segmentation faults and other potentially serious faults. And if memory cannot be procured, then paging is a viable alternative. However, paging leads to performance decreases, and it should be avoided at all costs. The last thing to talk about is caching. So virtual memory and caching share a few similarities. Both operate by breaking programs into pages or blocks and storing a majority of them in main memory. However, caching keeps all of its blocks in main memory. Additionally, when caching misses are handled by hardware rather than the software of the OS, which page faults are handled by. And the last thing is my sources. Thank you, and have a good day.